This example is a free response question from 2007 AP Physics B exam, and the question reads: the cylinder above contains an ideal gas and has a movable, frictionless piston of diameter d and mass m. The cylinder is in a laboratory with atmospheric pressure P atm. Express all algebraic answers in terms of the given quantities and fundamental constants. A. Initially, the piston is free to move, but remains in equilibrium. Determine each of the following. First, the force that the confined gas exerts on the piston. Second, the absolute pressure of the confined gas. Let's first draw a diagram. First of all, this piston exerts a force on the gas towards this direction, mg, and gas exerts a force on the piston, force gas, and the air molecules here exerts a force on the piston as well, force on the piston, F gas. We need to add FATM plus mg because the system is in equilibrium. We know that pressure is equal to F over area. Then force is equal to pressure ATM times area of the piston plus mg. Area of the piston is pi times d over 2, which is the radius, squared, plus mg. So the force that the confined gas exerts on the piston is equal to mg plus PATM times pi times d squared over 4. This was the first part. For the second part, we need to find the absolute pressure of the confined gas. Well, force is equal to F over area. Area is pi d squared over 4, and we found the force as PATM pi d squared over 4 plus mg. So actually, P absolute is equal to PATM plus 4mg over pi d squared. B part of the question is, if a net amount of heat is transferred to the confined gas when the piston is fixed, what happens to the pressure of the gas? If the piston is fixed, we can say that volume is constant. It doesn't change. And if heat is transferred, then temperature increases. When we consider the ideal gas law, PV equals nRT, as temperature increases, and since the volume is constant, pressure should increase, since N is the moles of gas and R is a constant. So we can say that pressure goes up. The question says explain your reasoning. You can easily say that if you heat up the system, temperature increases. Since the volume cannot change because the piston is fixed, pressure goes up. For the C part, in a certain process, the absolute pressure of the confined gas remains constant as the piston moves up a distance like so. Calculate the work done by the confined gas during the process. Work is defined as force times distance. Distances in this case xo, and we found that F gas is equal to PATM times pi d squared over 4 plus mg. If we multiply this by xo, we get work done. Here it says pressure remains constant. If the pressure remains constant, then force remains constant as well, since pressure is equal to force over area.